Hello and welcome to MySecurity TV and our Tech and Sec Weekly. My name is Chris Cubbage. I'm the Executive Editor with MySecurity Media, and today we're looking at some quite innovative research and new products coming out for the security sector from Australian universities. First up, Let There Be Light, a new tech to revolutionise night vision, and I've got Professor Dragomir Neshev, who is a Professor of Physics at the Australian National University and is also the Director at the Australian Research Council Centre of Excellence for Transformative Meta-Optical Systems, or TMOS. He does have some slides to share, so this will be a very interesting session, particularly if you're in anything to do with optics, night vision, or even the front line, but also on video systems as well. This looks like it has a range of applications. Then we're going to be going over to Adelaide and telling a complex tale. Researchers develop a narrative visualization tool for crime fighters. This has applications in defence, security, federal police in their crime investigations and court presentations as well. So we're going to be joined by Dr. James Walsh, Research Fellow with the Australian Research Centre for Interactive and Virtual Environments. So both quite innovative outcomes from Australian universities. We cover off on defence and national security, cybersecurity and critical technology, aerospace and space, and we'll cover on space next week, and cities and infrastructure. We should be streaming live on YouTube, LinkedIn and on Facebook. And today, I'd imagine we're going to go close to the full hour, but we have two guests with very interesting technologies. Just yesterday, and this is now available on demand on our Learn Security platform, Defending Critical Infrastructure from Ransomware Attacks. We were joined from Canada by Steve Ranville, the CEO of SIDEF, and also our partners in Delhi in India, Aerospace and Defence Consultants Association of India, and a good panel session there, and also a partnership signing between Canada and India. And also on Tuesday, our final episode, and these are now, all 4 episodes are available on our Learn Security platform on demand. And we were joined by a consultant panel looking at video surveillance systems and SEPTED. Also on Tuesday, our live Tech and Sec, we were joined by Brian DeCaries, the Chief Executive Officer with AEST, and recognising the critical role of the frontline security industry. That went for almost a full hour. So thank you to Brian for his time, but also covered quite a bit, particularly for relevant frontline security news and updates here in Australia. And also our recent podcast, particularly from Jane Lowe, her podcast with Microsoft, and also the Hasso-Plattner Institute there in Germany, particularly these two looking at malware, both disrupting malware and also how Bitcoin and the emerging role of Bitcoin in spreading malware is occurring as well. So both quite related. On Tuesday, I mentioned space. We're going to be having our Q2 market update with Dr. Chris Flaherty. He's with the MySpace Warfare Analysis Lab. And then also almost getting to the final call for contributions to our Cyber Risk Leaders magazine. And thank you to our sponsors, IT Glue, RSA Suite, and Secure ID, and also ALC and their cybersecurity certification courses. And a shout out, we're media partners and we'll be here at the Elevated Intelligence Security Exhibition and Conference 21 to the 23rd of July at the International Convention Centre in Sydney. Fingers crossed, given the situation here with COVID. And also, if you want to support the channel, please head to MySecTV.shop and our Cyber War series. So that's it from me, and let's bring on our guest, first guest for the morning, Professor Dragomir Neshev, Professor of Physics from the Australian National University. Dragomir, thanks for joining us.
Thank you, Chris. Welcome.
Very good. Night vision, and we had quite a good 10-minute pre-session interview, so I'm looking forward to this particular session, and really pretty much handing it over to you. You've come out with a piece of film that can create night vision capability on glasses, or it can be applied to even a CCTV camera. Maybe introduce us to TMOS, the Transformative Meta-Optical Systems. I like it. And that must have helped getting the funding when you went for the Research Centre funding. But introduce us to TMOS and your particular role there as director.
Thank you. So absolutely. So TMOS is a new Centre of Excellence funded by the Australian Research Council So for those of you who are not familiar with the Centers of Excellence, that is the elite program of the Australian government for strategic research in areas where Australia wants to make an impact. And we just started at the beginning of this year. And what the center wants to develop is a new type of optical technologies that have functionalities well beyond what is possible today. One of the examples is what we will talk today here about the night vision in ultra-thin film that can be applied even on, hopefully one day on spectacles.
Well, one question comes to mind. How many researchers do you have there? What's the sort of the broad scope of research that you're doing, and maybe then that'll allow us to see where this one fits in?
Yeah, thanks, Chris. So the center is a partnership between 5 universities. So Australian National University, University of Melbourne, University of University of Western Australia, and RMIT and UTS in Sydney.
Right.
So we have about 15 researchers, 15 chief investigators, and also a broad team, nearly 100 early career researchers and students. And the center aims at applying nanotechnology into the new generation of optics. And we have 3 main teams. One is on light generation, light manipulation, such as lenses, holograms, and the last one is on detection. But perhaps the things that fit most closely to security is the infrared vision and the possibility to see what is invisible to our eyes. And with this, we have a very broad program from the University of Melbourne, ANU, and University of Western Australia.
So you must be doing a lot in lasers. We have covered off on optics and lasers in optical fiber networks and that type of thing. So this one does look like it's slightly different. Maybe just talk us back, and you've got some slides to share, and no doubt the audience is like, okay, let us know what this is. So maybe introduce us to this research.
I'll tell you, of course, but just add also when you mention lasers, of course, we have a lot of lasers, and one of the big things is the lasers, which are very small, tiny lasers, like 1,000 lasers you can fit on a human hair, basically, so nano-type lasers. That's another very big part where we want to push in the center for generation of holograms out of your mobile phone. Like,
yeah, nice.
Big display.
Anyway, how far? Well, now you've got my attention. I'm interested in that. We'll definitely be having you back, Dragomir. But how far away is that type of technology?
So that's something that's really hard to predict. We do have the ingredients, so the single nano lasers are working, but making an array of a high definition display of nano lasers, that's something that beyond what we can imagine, very, very difficult. But we hope by the end of the center, which is 7 years from now, that we will have some prototypes also on this.
Yeah, no doubt. Okay, 7 years is plenty of time. We'll have you back on before then. So look, you do have some slides to share, and I think let's start talking about some of this technology.
Yeah, I wanted to share a few slides with regards to our night vision technology and how this compared to what is existing. So for those of you who have used some of these, this is an example of a current night vision binocular. And the issue with the current technology is that this is sitting usually on the head, and it's fairly heavy, so over a kilogram. Some of the more high quality devices. So it has a kind of severe impact if you're in security to wear this a whole day. So it's a fairly bulky, importantly obstructs the normal vision. So once you have this on, you don't see what is in the visible light. So non-transparent, and it's also a single color.
Yeah.
So what we have created is a ultra-thin film, which contains semiconductor nanocrystals. And what these nanocrystals help is to convert, to enhance the light inside the nanocrystal, to convert the color of the light from the infrared to a visible. And what this allows, this conversion happens in a thin film. So you can think this is a film which is 20 times thinner than a glad wrap, and contains inside this crystal. It's fully transparent. It's so thin, like as a glad wrap, you can apply to practically any transparent surface. and also allows a color vision and does not obstruct the usual vision that we have. So the way it works is just going to the next slide is in contrast to conventional night vision, which takes the infrared and puts it effectively makes it into the electrons, which are amplified and and only then gets detected on a screen. What we do is effectively taking the infrared light and boosting its energy with another laser to convert this infrared light to visible to be directly observed. And that could happen on a camera, as you said, in a CCTV camera, or could happen also one day directly on the spectacle. So this is kind of what we are inspired. One thing to mention is we're converting the short wavelength infrared. So for those of you who are familiar, so shortwave infrared is important because at night, even at pitch black, we have this night glow, which is extremely bright. And so the way it works is we take the infrared image, and for now the first prototype is image this infrared object onto our thin film, then send a pump laser together with the infrared object, and that allows to boost this energy from the infrared to the visible. And then we generate the visible image, which is detected on a camera. So the films that I mentioned, this is an electron microscope image of the film. So it's a polymer similar to a glad wrap, really, with the nanocrystals embedded inside. So you can see here one or two nanocrystals. It's about 20 times thinner than a conventional glad wrap. So it really can go to any surface. And as I said, it converts the night glow from the at the night, so pitch black night, converts the night glow to the visible. And just to explain a little bit to the audience, maybe going a little bit deeper, please interrupt me if I
go. No, keep going.
Too deep into the technology. But the conventional night vision goggles, what they do, they amplify near infrared light, so something that is up to 1 micron, pretty much of wavelength. And in this case, the effective scene or the effective illumination in this case is very much dependent on what on the ambient light from the moon or from the sky. So it's actually really changes if you have the altitude that you are or how much bright the moon is on that day. So it can change over 3 orders of magnitude, really.
So this is still sub-lux, so 0 lux and below, right?
Pretty much.
Yeah.
And contrast in the night glow, this is effectively a scattering from the sky, pretty much constant scattering, and is this area here around 1.5, 1.6 microns, and we have so much light there, even for our eyes that looks pitch black. We have light which you can only compare, just for comparison, what you will see if you have a perfectly full moon with a clear sky. So this is what we have there, and this is practically independent on the conditions or on where you are, what altitude you are on the screen. So this is this importance of the night glow, and that's why a lot of the night vision type technologies are aiming to detect this night glow. And this is what we have done. So this is a similar image of our nanofilms, and this is a nanofilm applied on a piece of glass, and you can see how transparent this is. Basically, once we add this laser that we have, additional laser, we can convert the shortwave infrared to visible. These are some of the images of the conversion as an example. So we have also in the lab, we have made images also with infrared cameras. So these are InGaAs, indium gallium arsenide cameras. They cost about $20,000-$30,000, so quite expensive. And some of the kind of top-end night vision goggles, they do implement such technologies, but they're extremely expensive and even more bulky than the conventional one. So we have taken such an image and we have applied the nanocrystal only in a small area. So just to make a comparison. So you see the infrared light is seen here in the grayscale. Then we go with this light through our nanocrystal type layer. that contains the nanocrystals, so that's not up to scale, but it just illustrates the nanocrystals in the layer. And once this is interacting, we see on a conventional camera, so this is pretty much a mobile phone type camera, we see this green light that is generated. And we use a typical example of a Siemens star. So this is a typical target that is used in testing the resolution and the conversion. We can see the images that are generated out of these stars, out of these Siemens stars directly into the infrared. So this is what we have done. So we just achieved these milestones where we have demonstrated this infrared imaging and the conversion. And so we are now at a pretty much an open field, like a way to take this technology next, and very happy.
Where do you fit here, Dragomir?
So this is our market kind of diagram where we want to.
So you can go into all of this.
So we can go to all of this, and what this means is the market value, so how much effectively the market is worth, and the difficulties in achieving that market.
Yeah.
So
look, we've got
just to be absolutely honest, we are down here in the bottom corner, and we want to go all the way up. But we do want to understand kind of what the business needs are. So in this stage of the development of technology, we do need to understand how the business sees this development and where things really can go. And sometimes as a researcher, we are not aware of particular things which business is thinking. And this is something that on overall we need to change, like these interactions between industry and academia, and improve the links much better. And this is something also what our center really aims to bridge this gap.
Well, I'll throw that out. Well, just in case we do have people watching that are in the visual, we do a lot with video systems. I mentioned CCTV. I sort of classify myself as a CCTV consultant. And, obviously you're dealing with low light level conditions, and although cameras are getting better in low light, but if you can start to apply this retrospectively on cameras and give them night vision. I've got a couple of questions. One is, you mentioned semiconductors in the crystals. Do they require power? You mentioned the laser being applied to boost it. It doesn't require any power?
So the laser is obviously connected to a power, but you can think about it like not sure if you are a biker. I ride a push bike, and I have this 10 watts flashlight which lasts for a couple of hours. So it's pretty much uses the same power that.
So it does require power?
Does require power, but it can be battery operated and potentially like much lighter than a conventional technology.
So even if you're thinking you're going to add it to some glasses into the future, the glasses will need a power source.
Would need to have some power source.
The other one is, well, that kind of answers my next question, is how long does it last? So if you did apply it to something, how long do those crystals last? Do they have a lifespan?
So the crystals are absolutely robust. So the crystal technology, semiconductor technology, is something that you will also have in your mobile phone. So it is very similar to the chip making of phones, except that we use these crystals for optical means. So they're not electrically connected in any way, and they only interact by light. So they are robust in this case. So the issues that we need to develop is how much the laser that powers up this conversion to visible can last, and that all depends on this efficiency as well. So at the moment we are at a low efficiency of the conversion.
Yeah,
we are working now in the research to reach much higher efficiency, to basically bridge over 1,000 times better efficiency. That will also help in this power consumption.
So I take it the crystals are the key aspect here. How do the crystals work? Less crystals, less vision; more crystals, more vision.
Let me go back to this image of the crystals. So the crystals are spaced sparsely inside the film, so that allows not to obstruct the the normal vision. So if you look through it, you don't see any obstruction. But because the infrared light has effectively a longer wavelength, so what these crystals make, they channel this longer wavelength, and they interact very strongly with this
reflection. I take it. Is it reflection?
Not really. So you can imagine, you can understand this like these crystals are resonators for the light, similar like a glass. I don't have a glass here, but this cup here will resonate to the sound wave. So in a very similar fashion, the nanocrystals resonate to the
got it. Okay.
And capture it inside, and the light intensity inside the crystal is actually 1,000 times higher than what is on the outside, and this is the key in this invention. So
I like it. That's a good way to explain it in terms of sound waves, and it resonates. Does it create the same kind of bright spots that you get in traditional night vision? You know, where you might be looking into the dark and it grabs all that ambient light, and then if you then go looking at spotlights and the like, it can blind you. How does it balance? Do they balance it off and balance that type of light, or do you get the same effect?
Thanks, Chris. So this is very important. So because the conventional kind of amplifiers or intensifiers, what they call, they do get blind if you make a flash of light visible or infrared. So what is important here, that in this case, in our case, the light is pretty much linearly transferred, so it doesn't have this saturation or blindness. However, it is so from my experience with talking to companies in this space, it is very important to understand the perception of our brain, how our brain perceives this infrared vision. So because effectively our technology is augmenting the real vision. If there is a bright light, you kind of pretty much just have your normal vision, but it's augmenting this with an infrared. And my understanding is sometimes our brains can get confused of this augmenting. So often companies do additional single processing and using artificial intelligence type technology to translate the infrared vision to something that our brain, it's easier for our brain to understand. So this is one of the aspects that we want to understand further. We have not worked in that direction, but we understand that this could be a potential issue to address.
Well, one of the key aspects is where you're at with this. You mentioned that you've applied for a patent. Have you got your patent, or you just applied?
So we have 2 patents on this. The first patent was granted in US and Australia. This is particularly on the development of the thin films with the nanocrystals. And the second patent is pending for US, European, and Japan and Australia. No, Australia is already accepted the second patent. We're still pending from US, which is potentially where the biggest market is there. So this is interesting. Yeah. So still trying to kind of not fight, but really to explain this technology to people who are really familiar with the conventional thing. So it's something that is really new, does not exist today on the market, and we are often kind of having these challenges in changing the perception of the people and the patent examiners as well, to explain the novelty of this technique.
Because I imagine there are the use of crystals and how they resonate, and both even with sound as well, but I take it also with light. May not be a new thing, but maybe in low light conditions. One of the key aspects that you've got in terms of the challenges for commercialization is, one, the potential size of the market. Maybe take us up to that slide where you've got the market opportunities there, and also the potential partners. Have you, where do you think you've had the most interest? Have you had any interest in this already from sort of defense or those in manufacturing in this field?
Thanks, Chris. So we do talk to at the moment with several defense companies, so those in the night vision for defense purposes, and the market is really interesting in this space, and we don't always understand the full complexity of the chain of development of the night vision technologies. But where we are at the moment is, and when we're talking to such defense companies, kind of integrating with the conventional technique. So we're having this our converter integrated with the conventional technique, which does use the intensifier, image intensifier. But what this allows is to extend the range of the vision of the conventional goggles. So our conversion screen is layers are so thin, so they can be immediately slotted in the conventional devices. And the first step of the market is extending this vision or range of vision. And the fact that that we have this additional laser that can be turned on and off allows to really augment properly in a conventional night vision device, to augment properly these two spectral ranges of the night vision. And just on this side, I want to make one analogy. So probably most of you use such kind of mobile phones, and the Apple at least has the Face ID, which does use a laser, which is 10-watt laser. So, and indeed augment this visible camera plus the infrared camera of this 10 watts laser for Face ID. So it's really compatible to this augmenting with the conventional technologies. So this is the first market. And of course, as I'm a science fiction freak, and you probably watching the latest Mission Impossible, but that was
or Broken Mirror. Broken Mirror comes to mind.
Or pressing your glasses, and then you start immediately enabling your night vision. So this is something that inspires me, at least.
I've got a question just on that. You mentioned on glasses, but given it's a power source, do you find there's an opportunity there for, say, contact lenses, and then using the human sort of electricity that we naturally have? If it's only on a contact lens, do you think it's capable of that?
One day, but it's because when we implement new technology, you have to be really careful in terms of safety. And one of the biggest questions that comes when we talk to industry, or you do have this powerful laser, can this somehow impact or be detrimental to the vision if somebody breaks?
It comes directly into the retina, yeah.
So if the glass breaks, would that
and the crystals, yeah,
and the crystal, exactly. So this film integrity is decreased. Would that would this light go to the eye and blind the person?
What's the source of the crystals?
So the crystals that we use at the moment are based on aluminum gallium arsenide. So this is a technology, as I said, is used in the mobile phone. So it's pretty conventional in terms of fabrication, and also in this thin film. So thin film kind of technology. So they use also as a kind of high efficiency solar cells in space.
So they're readily available.
Well, I wouldn't say readily, but the technology is established how to fabricate it. However, one of the disadvantages that the current crystals that we use have is that they do absorb part of the light that is being converted, the green light that we see. So we're trying to move to other type technologies, and we're looking at other type of nanocrystals. So just for sake of completeness, we'll mention this: a gallium phosphide and gallium nitride type technologies. And gallium nitride is what is used for blue LEDs. So again, there is a good type of industry there that is that knows how to process it. We're engaging also with this market people to do the supply chain of the technology. That is very important as well for us.
Well, very good. Look, fascinating, and just conscious of time now. But what is your call to action? Are you open to inquiries from industry seeing this video? and thinking, okay, that could apply to us. We had X-Tech on, I think last week or the week before. They're a defence robotics company, and I imagine if you're in the CCTV market, we're quite strong with contacts there. So what would be your call to action?
That is indeed our call of action, Chris. So we do want to engage with these companies to understand how the business develop and to push the technology in the direction that would make this impactful to our society.
Very good. Well, look, we've got a video systems and analytics series coming up. I think I'll keep you in mind for that, at least even just talking about how light works and how you can manipulate light. It's a very interesting piece of research that you're doing there in terms of that context. So, look, thank you so much. I'm going to let you go and backhand, but we were joined by Professor Dragomir Neshev, Professor of Physics, Australian National University, and the Director of the Australian Research Council Centre of Excellence for Transformative Meta-Optical Systems, or TMOS. Dragomir, thank you so much for your time, and I'll put you backstage. Look forward to talking to you next time. Thank you. Very good. Fascinating field. Just in case if you are listening and tuned in, let us know where you're listening from or say good day. And coming up next from that particular episode, Let There Be Light. Now we can tell a complex tale, and we're going to be joined by Dr. James Walsh, Research Fellow from the Australian Research Centre for Interactive and Virtual Environments. This is how they get their funds. They come up with these awesome centre names. James, thanks for joining us.
No worries, thanks for having me.
Researchers develop a narrative visualization tool for crime fighters, and I've done some large investigations in my time, so this sounds quite interesting. Introduce us to what you've been developing there at the University of South Australia.
So basically the project came out of a cooperative research centre called Data to Decisions, and basically they were given to look at big data problems within Australia. Their specific focus ended up being on basically national security, defence and policing, which is where we came into it. Obviously with modern case management systems, with Internet of Things, with all the sensors and investigative work that's going on, we're just getting more and more information that's getting put into these systems. And the problem is, how do we understand that? How do we communicate that? And how do we identify the gaps that we've got within that? So we basically came in to look at, well, if we have access to whatever information we want, now there's a separate problem of how do we get that information, but assuming we have it, what can we do with it? And that's really where this, I suppose, project came to be. Is looking at basically if we then bring on new investigators halfway through an investigation that's already underway, how do we get them up as possible? When we're doing that handover from the investigative side to the prosecution and then to the defense, how do we get them up to speed as quickly as possible? And basically just how do we minimize that loss of information along the way? Speaking to the investigators, one of the things that we really found early on was, as much as there are these modern case management systems and every investigator's got their own notebook, there's so much that's still retained mentally, and they've got this mind map of what's going on. And there is a little bit of a legislative reason, especially within policing, for why that is how it is. But we need to make sure that as much as possible, that's actually pulled out and communicated to everyone else involved in the case.
Can it be done in live stream, or there's a bit of processing in the background?
Absolutely. So what we designed was basically a visualization to sit atop existing systems. So it's not a system in itself. It's just a tool to show you what you've got.
Is it virtual? Is it like a virtual 3D or 2D?
So it's 2D, but it's got 3D components. So you can pull in point cloud scans. Speaking to the investigators, they're doing more and more 3D scanning of crime scenes, or if there's an industrial accident, they're scanning that in. So the visualization itself is 2D. We can pull in 3D elements. And I suppose for some of the more greenfields elements of the project, we have been looking at a virtual reality version as well. But the commercialized version will be 2D.
Okay, I've got a million questions for you, James. I'm ex-Homicide Squad, and also National Crime Authority as well. So I'm thinking organised crime sort of investigations, transnational organised crime, and then also homicide. Where are you pulling the data from? Is it just sort of machine learning and just pulling out all of those data points and just the keywords kind of sort of keyword mapping?
So it's effectively designed to sit atop the case management system or whatever data repositories that you've got. So it doesn't just have to be the one case management system. It can be other repositories.
Yeah.
The way that it works is basically then to pull that in and try and process, events that have taken place, etc. What we then do is basically try and create an understanding of what's gone. So, for example, Bob shot Bill. We have an action that's taken place. We've got someone that instigated that, and then we've got the passive recipient of whatever occurred. Once we have an understanding of that, it means rather than just looking at basically paragraphs of text or pieces of information or photos, whatever it may be, we've got an understanding of, at a really basic level, what's actually going on. What we tried to do early on was really remove a lot of the text-heavy representation that goes on for the investigations and the files that you guys are looking at. And what we found is, and I like to say that you have to have that Morgan Freeman voice. You can make the visualization as pretty as you want, but you have to say, and then he walked in the room, looked in the corner and saw whatever it may be. And without that Morgan Freeman voice, it's very, very hard to really provide the full context that you need. So you have to have that there at some level.
So this is automated, right? So this is naturally creating a narrative tool. And how do you manage the length of that narrative?
So it can get very, very long. You mentioned your history before in terms of homicide. I think it was ACC. So obviously you can have these huge cases that are going on. You can have drug cases that go on, multiple years.
We just had Operation Ironside, mate.
Yes, indeed. So definitely want to get the data sets for that.
Yeah.
One of the things that we do is basically, early on we wanted to say, look, which events are most important to the investigator? And they were very hesitant to even just put a flag as to, I think this is important, because that can be then disputed when it goes to the court of law. And this is where it starts to get differences between the different domains. But what we can then do is, depending on the domain, obviously if someone is shot, we can rank that as a high-level event. We go through and we try and give approximate values for the different types of events that have taken place in the story. And what we can then do is filter this 18 months down into basically, your 5-minute summary, your 10-minute summary. And that's actually designed that it can give you a little bit of the background, a little bit of where we're currently at, and a little bit about kind of where we are going in the future.
And I take it, can they pull out certain aspects of that to say, okay, within this time zone, we want to just pull out that and get a narrative on that?
Yeah, so you could drill further down. So effectively, you can kind of think of it like a tree, and you can kind of walk as far down a branch as you want. Otherwise, you can say, look, I'm done with this now. I'll go look at the next branch and what the next storyline tells us. And that really came out of the project was a collaboration with DST, Defense Science Technology Group. And they looked at a lot, obviously, telling narratives and this communication within the defense domain. So we work closely with them to make sure that we have the understanding, not just from the policing side, but from the defense and national security side.
So defense, you're applying it to a battle scenario?
So that's what they're looking at the moment. We've extended this into a couple of different domains, one of which was looking at applying for simulation, so effectively red on blue force simulation. If we've got this number of jets, frigates, whatever force mix you may have, if we run these simulations and we run it 1,000 times, 500,000 times, how can we start to understand actually what's going on across those simulations and trying to pull out and understand the decisive changes from one force configuration versus another one, and then try and make decisions based on that.
Do you keep the Morgan Freeman voice for the defence as well, or only for the police?
We do.
You've only got Morgan Freeman, have you? That's all you got?
We don't have the text-to-speech yet, but I'm keen to put it in.
Okay, well, there you go. So maybe that's a good question of where are you at with this? Is this a piece of research being developed, and you're now after the data sets, and is there AI being applied? This is going to learn on its own?
So the original project was basically just sitting on top of the existing repositories. It's moved forward in a couple of different areas. At the moment, the original IP is being commercialized primarily for government by GenX Ventures. They're based out of Melbourne. But the project itself, and I suppose the philosophy, has moved forward in a couple of other projects, one of which was that simulation project I just mentioned for DST. And that's moved forward again with a Defence Innovation Partnership, which is a South Australian government grant that we've been looking at for the past year for that, again on force simulation and trying to understand that in greater detail. The narrative visualization approach, which is basically just trying to understand what we're going on within a narrative context. We've now got a couple of other projects, the biggest one being with BAE, or British Aerospace, as part of the Innovative Manufacturing CRCs. There's a lot going on in terms of people have this information and it's just making sense of it.
So you can apply it to sort of large manufacturing projects as well?
Absolutely. Everything in terms of asset management. What's the story of this individual bolt within this component, within this system, within this piece of machinery or whatever it may be. And that becomes especially important, I think, for asset management, logistics. What's the story of this package? Where has it been? As humans, we're innately driven by the who, what, when, where, why. So it makes sense to try and understand the huge amounts of data that are being generated and collated within that narrative context. I think that's one of the big things for, you mentioned we're at the Australian Research Centre for Interactive and Virtual Environments, trying to figure out how we can basically generate these environments that really recreate everything that has gone on to date and help people understand that.
So basically it's a data science project, but then you are, as you say, narrating it. But this is just in that narration. There's nothing visual to this. This is just simply.
No, sorry. By narration, I mean narrative, just in terms of a story. So it is a visualization. The defense guys, the DST, actually have basically like a virtual news anchor. And this is something that
Am I out of a job, am I?
Project. You're almost out of a job. And that was really quite neat, in that it would literally be like kind of watching the 6 p.m. news, but it would be your defense update about whatever was going on in the battlefield, or if the soldiers are about to head out to do whatever recon that they need to do, getting them up to speed. And that's where it could be, look, I need the quick 30-second summary, and that's what they get, or I need the 5-minute briefing, or I need the full depth exploration.
Okay. So again, applying it to a major crime or a major investigation, the boss wants to hear the daily briefing. He can just get his daily briefing whenever he wants.
So we were speaking to basically where you do the national security hotline reporting, and once a week they have all the big wigs come in, and everyone has to basically plead their case as to where they get the resources to investigate things for the next week. And they said that we've only got basically a couple of minutes per person to make our impact, but whatever questions that were asked, we need to be able to drill down and pull up that specific information. So even though we can have this 2-minute high-level summary, you can then got a touchscreen version or a mouse, you can then tap on it and drill down into the underlying information, or kind of get that extra information that they're wanting. Because obviously, if you've only got that short time frame, that's what you need to go for. If we're doing the onboarding of the new investigation, then we can go through every single little detail, license plate numbers, all of that. But we don't care about that for the 30-second summary.
Now, so I see defence, I see major crime, and most of, say, a crime management platform will keep all those keywords, pretty much everything. You can then start to do that search, and it will start to map it, like analytical tools and the data wheels and the matching. So there's a lot of visualization in them already. Where would you say your key differentiation is from that? Is it the narrative side, putting it into a story?
Absolutely, the narrative.
And maybe
side.
how do you do that? What's the secret sauce there?
So a lot of the systems that are out there have kind of the individual visualizations that you can pull up, whether that's a social network map or whatever it may be. I think the big thing is understanding and trying to piece everything together, and that's obviously a very hard challenge. And like I said, kind of not shying away from that Morgan Freeman, that you have to have that voice there. You have to have some kind of text to get that context, and not shying away from that. So it's then pulling in materials around that, and it's then just having an awareness and an understanding of the provenance of information. We know this because it came from here. It came from here because Bob told us. So it's then having that whole understanding of where this information came from, what transformation it's gone under, and then how that impacts what you've got now. Just because we have a fact, that doesn't mean the fact is true. If we learned it from a dodgy drug dealer versus if we learned it from a Telstra customer report, we can then have different ratings of, I suppose, trust associated to that. So we need to then have an understanding that just because it is there in the story, it doesn't mean that we should necessarily trust or rely on it.
We haven't mentioned, we covered quite a bit on cybersecurity, and have you looked at applying this in a cybersecurity context, or a crisis context as well? Absolutely.
So we put in a grant, haven't heard back on that one yet, but we are looking in applying this basically in every domain out there. Cybersecurity is a big one. We're seeing this more and more, obviously, with the recent hacks in the US and in Australia, not just but also in terms of the exfiltration of data as well. And I think that's only going to be a domain that's going to be growing in importance. Moving forward, also then looking at space. Obviously, we've got the Space Centre now that's set up in Adelaide as well. So there's a number of different domains where really understanding this information is absolutely critical. Obviously, there's common themes across that, but then there's also differentiations between the different domain applications.
Okay, so how is it applied? Is it a cloud-based platform, or is it a what is it? And then how do you upload the data sets? And does it need any specific data sets in their format?
So at the moment, originally it was developed basically in a game engine. So because we come from interactive and virtual environments, we do a lot of our work in game engines. We want to do it in virtual reality, web version. If we want a desktop version, we can generate that. Where the commercialization going is basically turning it into web version. So you can load up your browser, you can log into your workplace portal, and then you can fire it up from there. That can then either consist of loading in data via an upload from your desktop, or then potentially have that fed into whatever data silos you've got sitting behind that. So I suppose that's where the commercialization and the refinement really comes in terms of taking it from a research tool into actually something that fits existing workflows that are out there.
So again, it's in a single game engine.
It started off in a game engine, but now it is literally just a web page that you log onto, and then you've got your visualization there. That data then can be fed from an upload from your desktop, or it can be then linked into your organization's repositories. Basically, when you give us data, what we go through is try and extract the locations, the entities, the timestamps, the events that have taken place, and that's what then feeds into it. Obviously, if you've got a case management system, if you are the AFP or if you are SAPOL, you are going to have a case management system that has large chunks of that information in there, but there's always going to be a lot more data that is unstructured than what we've got that's structured. So we have to try and pull as much as we can out, either as the core resource or a supplementary resource. It's not going to be the same as someone manually curating it by hand, but it's sure as hell better than having none of that information at all, easily accessible.
What are some of the limitations to this, do you think? I can see it from another crime fighting tool, particularly on your case management and maybe operational management as well. What about for court? So there was mentioned here it's been used in, say, child protection. Do you see it getting to the jury as a tool?
I think so, absolutely. So we had a couple of different PhD students that were working on other facets of the project. One of them was looking purely at the jury in the courtroom scenario. We had another one that was actually looking at CCTV. So there are a couple of different prongs. I think the cases that we're getting put in the courtroom now are becoming more and more complex and more domain specific, and tech is becoming a bigger part of them. And I think we have juries that are just normal end users that don't have that. We need better tools to help communicate these cases, both for defense and the prosecution in the courtroom. You mentioned child protection. That is one of the big domains that we're looking at kind of straight out the gate, both in terms of the legal and the policing side for it, but even just when they go to place kids in homes, which foster carer is in the best spot to take care of this child? What's this child's history? Do they have a history of certain behaviors, or if they have these behaviors, do other kids have these behaviors, and why do they all have these behaviors? So it's then, I suppose, kind of starting to go down a little bit more of the mining thing of, if we are noticing something's off, how can we then jump back into the story of this kid for the past year, 18 months, 2 years, 3 years, 4 years, and then we might find that other kids have had similar behavioral issues, and then have they all come out of the same foster care home? What's the story there? But there's a lot there of, this kid's being collected by child services today. We need to place him tonight. Where are we going to put them? So you
have to brief that case officer.
Yeah. So we need to have the ideal matching of the resources that we have to the information that we've got coming in. And then when we do actually drop that child off at that person's front door, that's the first time they've met them. So how do they get up to speed with the last, up to 18 years of this child's life to make sure they can support them the best way they can, as quickly as they possibly can?
How innovative is this, James, in terms of, are you hearing or seeing other narrative tools out there? Maybe, and what is the background to this type of research that's been occurring? I
think the narrative visualizations really only started kind of the last maybe 6 or 7 years, and really kind of hitting its stride in the last 3 or 4. It can come in many forms. I mean, if you look at comic books, that's a narrative visualization. You're visualizing the narrative there. So there's a number of different ways that you can do that. At news media, you've got more and more infographics. So if you read the New York Times, or even the Australian, we're seeing more and more interactive tools to actually explore. Is
that a good analogy in terms it turns into a large book into a comic that you can scan through?
At a high level, anything to kind of help you understand it. But you're seeing more and more for the news. They're having these little widgets. ABC is doing a lot of that. For their kind of narrative visualization as well. And I think that's just showing the applications of this, but B, really just how it helps people understand the information, even if they don't have that technical background.
And just cutting out all the noise, basically, cutting out the noise and getting to those key points.
Exactly. One of the other things that we found really interesting was we were speaking to the ATO about the tool, because obviously they were interested with the applications for it. And they said, look, we'll start doing an investigation because someone was avoiding taxes, but it turns out they were avoiding taxes because of motorcycle gangs, prostitutions, drugs, guns, whatever it may be. So we then pull in this other unit, then focuses on the motorcycle gangs, and someone else focuses on the drugs, someone else focuses on prostitution, whatever it may be. So one of the things that's really neat about the tool is we have an understanding of what the person that's using the tool is actually interested in. When we do that filtering down to the 5-minute summary or the 3-minute summary, it can actually focus and be tailored towards the kinds of events that person actually wants. And now if I'm doing our 5-minute briefing to a superior that has a background in motorcycle gangs, it's tailored to that versus the briefing to the superior that's focused on the tax and the financial side of it. Obviously, there's the overlap there, but there's a few different stories there within that overarching arc.
Look, it's fascinating. I'd like to see it. And maybe I'll just it's not obviously Dr. James Walsh doing all this. He's also working with Dr. Andrew Cunningham and Professor Bruce Thomas there as well. And this is James, you're a postdoctoral researcher with University of South Australia STEM. How long have you been working on this?
So the project started 2014, 2015. And then that was collaborating heavily with, I suppose, the AFP. So we're working with AFP agents there talking about their problems. And that's where this was heavily driven and I suppose tailored to their initial use case. But then moving out from there, obviously our collaboration with DST as part of the project that then brought in the defense side of that. And then once we effectively had that prototype to shop around, then engaging the ATO and the other different government agencies, whether that's geospatial, whether that's actually the ADF, looking at how that can actually be applied to their specific domain.
And where are you now in terms of, are you heading to commercialization, or you are a commercial? Well,
so
you're a day
we're not handling that ourselves. Gen X Ventures are handling that. So they've acquired the IP from the research center. We're still working with them to basically do that commercialization and then further move forward with continued R&D in the different domains. So again, it's looking at, well, we've got this tool originally within the defense and national security space. How do we then customize that to the child protection domain? How do we customize that to the logistics and the asset management domain? And then what does that introduce? And effectively making sure that we can still have one tool, but it can then be that jack of all trades that we need for those different use cases.
Like a data narrative tool as a service, software as a service as a approach. Yeah, right.
I think. Sorry, you go.
I was going to go off topic. Go with yours.
So I was just going to say one more thing. You mentioned in terms of what's different for our system. One of the things that was really interesting that I didn't mention before was, I go back to the Lord of the Rings analogy, that a lot of the case management tools are very focused on the chronology, which makes sense. You need to understand that chronology. But in terms of getting people up to speed, it doesn't really work as effectively as actually focusing on Bob for a certain period of time and then focusing on Alice and whoever it may be. So if you watch The Lord of the Rings in chronological order, very hard to watch. You keep jumping between what all the different characters are doing. But if we just focus on certain elements for a certain, then we can get up to speed, gain that understanding, and then move on to someone else. I think
gives
that was
one context
of the
as well.
Exactly. One of the really big, I suppose, kind of points of differentiation between what we've got versus what's already included in the existing off-the-shelf tools.
Okay, interesting. And obviously that gaming engine gives you that power, but also the crunching of that data, and which is, again, it's just slightly different. Is this using high performance computing? What kind of computing power do you need in the background?
So at the moment, it just runs on a standard desktop. The game engines really allow us to basically go in whichever way we want to go. If we want to go into a web version, which is what we've got now, we can do that. If we want a desktop, if we want a tablet, if we want a mobile, or if we want to go virtual reality. And like I said, we did actually explore that as part of that for a more geospatial focused version of it. And it really gives us that flexibility for whatever we want to do, that the whole system has been built up in a games platform that we can then translate into whatever we need to do. Right. That is something that is obviously changing a little bit with the commercialization, that is becoming more of a web product. But for most of our R&D these days, we use game engines, either Unity or Unreal. And that gives us the flexibility to effectively kind of pivot to whatever direction we need. If we want to pull in something else, we do a lot of augmented reality as well. So you've got the HoloLens, you can then put the HoloLens on and see other information pop up in front of you as well. So it's all built from the ground up with that flexibility to go in whichever direction we need to.
Sounds friggin' awesome. I really like it. And I noticed we did a podcast, or Jane did a podcast, our Singapore correspondent, with Murdoch University using virtual reality for crime scene investigation, and then walking people through crime scenes in a virtual environment. So I think if you're already getting a narrative in a virtual environment and you're moving to other virtual environments to deep dive, that sounds like the future I always thought was coming. So it sounds like it's starting to arrive. James, the question I had for you, what's your background? What's your sort of domain of research and expertise? Where have you come from?
So my background was in user interfaces, visualization, and effectively just human-computer interaction, and looking at just how we can basically make that seamless, make that more natural. There's a lot that we do that we still do just because it's a learned response. Even though your iPhone feels incredibly simple to use, it's because there's still a lot of learned responses there. What we're looking to do, obviously, at the center is it's just about basically making interaction as natural as it possibly can be, whether that's with information, whether that's controlling systems for machinery or the new submarines or the frigates, whatever it may be, just helping simplify and make human-computer interaction much more natural.
Very nice. Okay, well, you're never going to run out of work. Well, not for a while anyway. But look, I do appreciate it, James. Final call to action. Are you? Is this just to get the word out there? What would be your call to action to finish off?
Call to action is, if you're interested in the work, please do reach out. Obviously, for myself at the university, Dr. Andrew Cunningham, Professor Bruce Thomas. We are here to basically address your needs. We are here to work with industry to try and help you understand and address your problems. So if you do think this tool could be potentially usable, or a variation of this tool, or you've got a similar problem, please do reach out, because we are here to help in any way we possibly can.
Great, I love it. Look, thank you, Dr. James Walsh, Research Fellow from the Australian Research Centre for Interactive and Virtual Environments at the University of South Australia. Thank you very much, mate. I'll let you go. Enjoy your day. And this will be out as an edited version as well. But thanks, James.
No worries. Cheers.
Cheers, mate. Bye-bye. Very good. Fascinating morning on looking at these two. And let me just hide that one, sort this out. And as I do, just to finish off for the report of the day. Now, the more I looked at this one, the more I got deep dived into this one. This could be a good one for James. This is the European Union Terrorism Situation and Trend Report. This is a detailed report with a lot of findings. It was just too many to even highlight. A couple of here that I pulled out. Numbers of terrorist attacks appear to have remained largely stable during COVID. Numbers of terrorist arrests dropped significantly, and there was some scale on that. But yeah, significant drop in arrests, particularly obviously in Europe. This is Europol. Suspects arrested for planning right-wing terrorist or extremist attacks are increasingly young in age, and some are minors. And COVID-19 did not fundamentally modify core terrorist modo operandi, or MO. So look, that's it's on the marketplace for downloads. It's worth having a look at that, and there's a lot of information. And there'll be a few, I know, like the likes of ASPI, but even our own law enforcement agencies would be interested in that report. We return on Tuesday afternoon at 3 o'clock Sydney Eastern Standard Time for our Q2, Quarter 2 2021 market update on the space and defence sector with Dr. Chris Flaherty. And I've seen some of his slides coming through. That's on our spaceanddefence.io channel. Welcome to check that out and join us on Tuesday afternoon. But otherwise, that is us for today. Thank you very much for joining us on our Tech and Sec Weekly. Enjoy your weekend, and we'll be back on Tuesday. Thank you.